Hi, today we're going over section 6.2, which deals with geometric series. Now, if the differences between series and sequences is essentially with sequences, we listed out all of our terms with commas in between them. With series, instead of having commas between them, we put plus signs between them, and essentially we add up a geometric series. So we have a couple different equations that we'll use to add up the terms of a geometric sequence. So Sn represents the sum of our series. T1 is our first term in that series. N is our number of terms. R is our common ratio. L is our last term. So we've got two separate equations. We've got Sn is equal to T1 times 1 minus R to N over 1 minus R. And we also have Sn equals T1 minus R times my last term over 1 minus R. So this one we'd use if we know how many terms there are and don't know our last term. This one we would use if we know our last term, but we don't know how many terms there are. So for example, determine the sum of first 12 terms of this series. So we've got 3, 12, 48, 192, and it continues on for 12 terms. So first, we'll look at this. So our T1 is 3. Our ratio will still take our second term, divide by our first term. So 12 divided by 3 gives us a ratio of 4. Sum of first 12 terms means that our n is 12. So in this case, we know how many terms there are. We don't know our last term. So the equation that we'll utilize is Sn is equal to T1 times 1 minus R to the power of n over 1 minus R. So we're looking for the sum of 12 terms. So we've got S subscript 12 is equal to T1, which is 3, times 1 minus 4 to the power of 12 over 1 minus 4. Now, if we go through and simplify this, that gives us 3 times 1 minus 16,777,216 divided by negative 3. So calculating that gives us 16,777,215. Next example, the sum of first 14 terms in a geometric series is 16,383. The common ratio is -2. Determine T1. So once again, we'll start by writing out what information we have. So we know we've got 14 terms. So we know n is equal to 14. Then they tell us the sum. So we know S of 14 is 16,383. We're given R is equal to -2, and we want to solve for T1. Now, based off this information, I would use the same equation as we just had in the previous example. So we've got Sn is equal to T1 times 1 minus R to the power of n over 1 minus R. Now, in this case, we want to solve for T1. So we need to rearrange this to get T1 on its own. So first thing I would do is move this 1 minus R to the upper side. So I'll multiply both sides by 1 minus R. So that gives us Sn times 1 minus R is equal to T1 times 1 minus R to the power of n. We then want to get T1 on its own by dividing both sides by 1 minus r to the power of n. So that gives us Sn times 1 minus r over 1 minus r to the power of n gives us our T1. At this point, we'll start filling in our values. So we have Sn, which is 16,383 times 1 minus -2 over 1 minus -2 to the power of 14 is equal to T1. So that gives us 16,383 times 3 divided by 1 minus 16,384 is equal to T1. Calculating this gives us -3 is our first term. Okay, next example, calculate the sum of -3, -15, -175, ... -46,875. So in this case, we don't know our number of terms, but we have our last term. So we have term 1 equals -3. Our r would be -15 divided by -3, so that would be 5. And we know our last term is -46,875. Now, because of this information, the equation we'll use is Sn is equal to T1 minus r times our last term over 1 minus r. So we have Sn is equal to T1, which is -3, minus 5 times -46,875. And that's over 1 minus 5. So go through and start simplifying this. So we have -3 plus 234,375 divided by -4. Calculating this gives us a sum of -58,593. Okay, so next we're going to look at sigma notation. So sigma notation is when we have this symbol here. That symbol means the sum of. And essentially it gives us an equation with a variable in it. And the value it gives us below is our first value that we put in our equation. And then we keep increasing this value until we get to the value at the top here. So for this one, it would be for the values from 1 to 4. And we know that because it starts at 1, and then this number at the top is 4. So essentially, if we were calculating this, this would be the same as 10 times 2 to the power of 1 minus 1 plus 10 times 2 to the 2 minus 1 plus 10 times 2 to the 3 minus 1 plus 10 times 2 to 4 minus 1. So we've gone from a value of 1 here to a value of 4 here. Okay, so for this geometric series, we want to write out our first 4 terms. Now, we can see our first k value is 1, so we'll start by writing term 1. So our term 1 is essentially negative 3 times 5, and then we've got 1 minus 1. So we've got term 1 is equal to negative 3 times 5 to the power 0. Anything to the power 0 is 1. So our term 1 is just negative 3. Now, as you may have noticed, this is our ratio. So I can now, to get our next terms, simply multiply by this ratio. So term 2 would be negative 15. Term 3 would be negative 75. And then we have term 4 is negative 375.